This is maximum sum subarray of size k problem, and you already know that you already complete the two pointer pattern. Okay, and right from today onwards we are going to start the sliding window pattern, and this is the very first problem of sliding window pattern. Okay, and you can see the problem is nothing but max sum subarray of size k. Okay, so basically we are given an array of integers array arr, you can say, and the size is nothing but n, and we are also given a number k, and basically we need to return the maximum sum. Okay, maximum sum of subarray of size k. Okay, so you can you'll able to understand with this example actually. So you can say this is, let's say this is the array. Okay, and we are given this k. Okay, so what I need to do, we need to find, okay, we need to find maximum sum for a particular subarray that will be nothing but the length of k. Okay, so you can say the k is 2. Okay, so basically we need to find, okay, such subarray sum of size k, or two size subarray sum that will be maximum. Okay, we can, let's say this is the array. Okay, so you can say if we take the this two array, this two size subarray, we will able to see the sum is nothing but 300. Okay, if we take this, then the sum will be nothing but 500. Okay, if we take this, the sum will be nothing but 700. So maximum sum, okay, of in subarray size 2 will be 700. Okay, that's why we need to return this 700. Okay, now let's analyze this example so that we can solve this. Okay, so this is the example you can see. So first of all, you can see this is the array, we can say, and we are given k as 2. Okay, so what I need to do, we need to find a subarray of length 2. Okay, and then we need to simply get the sum. So you can see if we find the subarray, so you can see this is a subarray of length 2, this is another subarray of length 2, and this is another subarray of length 2. Okay, so basically what I need to do, we need to take this sum. So you can see the sum for this subarray is nothing but 300. Okay, and for this subarray the sum is nothing but what, 500. Okay, and for this subarray the sum is nothing but 700. So what I need to do, and we just need to return the maximum sum. So you can say this is the maximum sum, so we need to return 700. Discuss the approach we can follow. Okay, so you can see this is the array, and so we can, what we can do, we can use a loop. Let's say we have a loop. Okay, let's say we have a for loop to iterate through the array. Let's say I will be the iterator, so I'll start from 0 and it will go to up to n. Okay, so that is the thing. Okay, and what I need to do, and we just need to find a subarray of length k size length, right? So what you can do, we can take another loop that will be inner loop. Okay, so let's say inner loop will start from I index, and it will go, it will go, that means j can go up to, you can say this I plus k. Okay, so you can say this is the inner loop. So with the help of this, will able to find the subarray of length k size, and every time in this inner loop we just need to take the sum. Okay, we just need to take the sum of the current element for the array. So you can say first of all, the for the outer loop, the array will, it will start, I will start from here. So for the first loop, j will start from here to here. Okay, because we have two sides, so simply we need to take the sum of this subarray, and we just need to save within some variable. So first of all, our sum will be 300. Okay, then for the next iteration, I will be here. Okay, and j will start from here to here. For this subarray will be sum nothing but 500. Okay, and similarly for this array also will be having some 700, and this will be maximum, so we just need to return this. Okay, so basically if we right now, if we talk about the time complex, so you can say this is the outer loop will run up to n. So for the outer loop, the time complexity is nothing but big of n, and for the inner loop it will only run up to k times, so the time complexity is big of k. So overall time complexity will be, you can say, this is nothing but n into k. So this is the overall time complexity, but we have some better approach, okay, to solve this problem, and that will be nothing but using sliding window approach. Okay, so now let's discuss the sliding window process. So for sliding window, we just need to have a start pointer. Let's say our start pointer will start from 0. Okay, it will start from here, and we need to return the maximum sum. So we need to take a variable as maximum sum. Let's say it will be minimum possible value. So let's say it is 0, or you can assign with minus infinite. Okay, and we also need to have a sum, okay, just to count the sum of the array, okay, throughout. So now what I need to do, we need to simply iterate through the array, okay, and let's say I will start from 0 and it will go to n, okay. So every time what I need to do in this array, every time what to do in this iteration, every time we need to add the current element to this sum variable. So let's say sum will be nothing but the current element. Let's say current element is pv, okay, this is the current element, okay. And also also what I need to do, we need to check the difference, because we need to for the first time this is the window of size k, so we need the sum of this window. So every time we just need to take the difference, right? So that will be nothing but I minus the starting point. If this difference is equals to k minus 1, okay, window size minus 1, because this is 0 indexes, that's why, okay, we are taking k minus 1. If this difference is equal to k minus 1, that means we got required subarray, okay, of size k. Then we simply need to compare the this sum with the maximum sum, okay, this sum with maximum sum. If this sum is greater than, then what I need to do, we need to maximum sum will be nothing but max of this maximum sum, max of this maximum sum, and the current sum, okay. And every time what I need to do, every time we need to shift the window to find the next one. So if we shift the window, you can say the right now the start pointer should point here, because this will be the start pointer for the second window or second subarray. And we also need to subtract this sum from the overall sum, right? So we need to perform two operations. Basically we need, first of all we need to reduce the sum. So sum will be nothing but, you can say, the array of, we just need to reduce this start pointer value, right? And again we need to increase the start pointer, okay. That's it, that will be the whole process that we need to do, okay, to solve this problem, okay. And last of all we just need to return the maximum sum, okay. We just need to return the maximum sum. This will be the whole process. Now let's jump towards the code section so that we can code this approach. So you can say we are given the array list, okay. So what I need to do, we just need to, first of all we need to have some variables. First one will be, we just need to return long type, you can say, okay. So let's long maximum sum, let's say max, okay, max sum that we need to return. And let's say we are initializing this max sum value with 0 or 0, okay. And we just need to have another long type for sum, just to store the current sum of the element, okay. And we'll be having a start pointer, let's say start will be, let's say it will start from 0, okay. Now let iterate through the array list. So that's why we just need to have index I will start from 0 and it will till n, we are given n, okay. And every time I will increase by 1. So now what I need to do, first of all we need to add this to the sum. So sum will be plus equals this current element. So we can get this current element using arr dot get, using this get method, get I, okay. And every time we just need to check the difference, and that difference is nothing but I minus what, I minus start, okay. If this difference is equals to we can say k minus 1, then we need to what, we first of all we need to check the sum with this maximum sum. So we can use the just what I need to do, this max sum will be nothing but math dot max of max sum and current sum, okay. And we also need to do two operations. First of all we need to shift the window, right? So to shift the window you also need to reduce the value of the start pointer. So now the sum will be minus equals to you know ar array this dot get, my bad, this will be get, and the index will be start index. We need to reduce this value and we need to index the start pointer, okay, by Okay, my bad. By one place. Okay, that's the thing. And when we'll be out of this loop, we need to simply return the maximum. Now let's run this code. Okay, it's taking time. So you can say it's giving the right output. Now let's submit this code to check whether it gets submitted or not. Okay, it's just running against test cases and you can see it get accepted. Okay, so this is the thing, and you already discussed the complexity. That time complex is nothing but big of n because we are only iterating through the array. Okay, and yeah, this is the constant operation, that's why, and we're also using constant space. Yeah, and that's it.